Alright, in this video we're going to finish up the notes, the 5.3 notes. Start you off with a review problem from yesterday, one that puts both together, and then we're going to learn something called grouping. And we use grouping when you have four terms, four or more I should say. So we came up with patterns for two terms for binomials, and to factor a binomial you need either a square minus square, or a cube plus cube, or a cube minus cube. And then we've got the trinomials are possible if your lead degree is even and the exponent in the middle is half of that, half of degree. And then you've got just a plain old constant number on the end. So this fits that description where your degree is even. Your 6 is even, and then in the middle of half that, x to the third, 3 is half that, and then you got a constant term, just an 8 at the end, or a minus 8. So if that happens, you're going to try to figure out what times what is negative 8 and adds up to 7. Well, that'd be negative 8 plus 1. But you can't just have x and x. If I had x and x, that'd give me x squared minus 7x, or plus 7x. I got these backwards. Let's fix that right now. Should have been positive 7, so we want a positive 8 and a negative 1. Okay, so if we multiply those up, we would have x squared in front, x in the middle. We want x to the sixth in front and x to the third in the middle. So we need to change these to x cubed here and here. Now when you multiply them out, you get x to the sixth in front and x to the third in the middle. Well, this isn't done because this is our new pattern. This is cube plus cube and cube minus cube. X to the third plus 8 is x cubed plus 2 cubed. And x to the cube minus 1 is x cubed minus 1 cubed. How do I factor x cubed plus 2 cubed? Well, I write down the x plus 2, just ignore the cubes. And then I do first one squared. Opposite of the product, x times 2 is 2x. So we make it negative 2x. And last one squared to be plus 4. Now I go over this one, write down what's with the cubes, the base of the cubes, only leave the cubes out of it, so x minus 1. And then I do first one squared, opposite of the product, last one squared. That is the factorization of that trinomial with degree 6. So when I factor that trinomial with degree 6, I end up with 4 factors. I get 2 linear factors here, here, those are linear, 2 linear binomial factors, and I get 2 quadratic factors. There's a quadratic and there's a quadratic. Alright, so what's the main part of today? We're going to factor polynomials that have 4 terms in them today. This has 4 terms. So we've got to do something different, and we're going to do what's called grouping. Now, grouping doesn't always work, so that's the bummer of it. When it does work, it's kind of nice. What you're going to do is take these 4 and group them into 2 pairs. Before I do that, see if anything goes into all 4 terms. And there's nothing that goes into all 4. So we don't have to worry about that. We're just going to group them into 2 sets. Now, this doesn't always work this way, but I'm going to try taking the first 2 and the second 2. I might have to do the first one with the third one, or the first one with the fourth one. I got to try until I come up with something that may work, but it doesn't have to work. So how does it work? We've got our 2 binomials here, you factor them individually. What goes into both these terms up here? X squared. If I take out an x squared, I get x minus 2. What goes into both these terms right here? 9, but I have to take out a negative 9. I take out the negative 9 so that, well, we always factor out a negative when that lead term's negative, but the importance of this is when I take it out, I end up getting an x, a positive x, and a minus 2. And that's what I want. I want to get 2 of the exact same binomials. When I have 2 of the exact same binomials, I now can write this in a different form. I can say x squared minus 9 goes together, and x minus 2 goes together, but you only write those once. Now some people mess up. They think we're going to put a square here, but that's not right. You don't put a square here. If I told you to FOIL out x squared minus 9 and x minus 2, you would end up with what I have up top. If I told you to FOIL out, you would say, I'm going to take x squared times both of these. And that's what that is right there. There's x squared times both of these. And then you would say, I'm going to take negative 9 times both of these. And that's what this is right here. So I don't need 2x minus 2s, I just need 1. So again, we got x squared minus 9, x minus 2. That's not totally factored. X squared minus 9 is a square minus a square. Square root of both, got 1 plus, 1 minus. And then leave your x minus 2. That's the factorization. I said make it equal 0 and solve, so your answers are negative 3, 3, and 2. Okay, let's try going in order with number 8. We're going to group the first two. We'll group the second two, but be aware that it may not work out. If I group the first two, what goes into both looks like x squared. And that would leave me with a y squared minus 3 on the inside. In order for this to work, the second one needs to have a y squared minus 3 on the inside. What goes into both? Negative 4y squared and 12, negative 4. And that would leave me with y squared minus 3. Because negative 12 or 12 divided by negative 4 is negative 3. So we're happy here. We've got the y squared minus 3 we're looking for. So I've got x squared minus 4 and y squared minus 3. We only write one of those because we're undoing our FOIL. And x squared minus 4 is a square minus square, so we turn that into x plus 2x minus 2. And then we leave the y squared minus 3. Didn't have to solve on this one, just had to factor. Okay, example 9. Let's see if we can get away with it again. Let's see if the first two and the second two work. So plus 27, you got to remember that. What goes in the first two? 2x squared. 18 divided by 2 is 9, so I get a 9x. Minus 2x squared divided by 2x squared is 1. Doesn't disappear, it becomes 1. What goes into both 27 and 3? Well, 3 does, plus 3, because that was a positive 27 up here. And that will leave me at 9x minus 1. That's what I want. I've got 2 9x minus 1. So the factorization would be 2x squared plus 3 and 9x minus 1. This one I said solve. What makes me equal 0? So you have to make 2x squared plus 3 equals 0. That'd be 2x squared equals negative 3. That'd be x squared equals negative 3 halves. That turns into plus or minus square root 6 over 2i. We've got square root of negative 3 halves. That's I times square root 3 over square root 2. Multiply top and bottom by root 2, and you get square root 6 over 2. So that's where that one came from. And this one's simply 1/9. What makes 9x minus 1 equals 0? Add 1, divide by 9. So there's your answers. I want to show you a way to, let's see if I could regroup these and get it to work. What would have happened if I would have put the 18x cubed and the 27x next to one another, and then wrote minus 2x squared plus 3? Let's try to group it that way. What I would take out of there? 9x, that would give me 2x squared plus 3. And what goes into both of these? Negative 1. You have to put negative 1. Now, if nothing went into both of those, you put plus 1, and then in parentheses. Well, here I get 2x squared minus 3, which I believe that's what I was supposed to get over here, or no. Let's see. Oh, this was, I wrote it down wrong. So this was a minus right here. All right, so this is 2x squared plus 3 as well. Sorry about that. So it was negative 2x squared minus 3. Take out a negative 1 and you get 2x squared plus 3, which is what I want. And then you would end up with 9x minus 1 and 2x squared plus 3, just like I had before. The reason I did this extra one is because if you did it this way, you would have to put minus 1 here. People tend to forget the minus 1. Don't be that guy. Here I want to show how you can get your calculator to get the zeros. Well, we're only going to get the real zeros. I'm using the problem from up above here. So I know I should get an answer of 1/9. And 1/9 is 0.1 repeating. I'm not going to be able to get the imaginary answers with my calculator, but I'll show you how you get the answer 1/9 with your calculator. Bring up the calculator. Type in the function. I've got that all typed in. I'll do a zoom. 6. And I can see that, oh, excuse me, I can see that, oh, I'm thinking I maybe have the wrong function in here. Yep. So we've got to retype. 18 x cubed minus 2x squared plus 27x minus 3. Okay, now let's try it. Let's graph that. I can see it hits the x-axis once. The end behavior of this should be like a line that goes up because it's x to the third, and that's what it looks like, a line that goes up. So what I'm interested in is what's the x right there. Now we've done this before, but I'll do it again here. Second trace. We want to find a 0 on this one. So number 2. Am I to the left of my 0? Yep, I'm blinking just to the left. I got an arrow right to get closer. So I'm to the left, press enter, get to the right. There, that's to the right. Press enter. Would you like me to guess? And hopefully I get an x of 0.11. Oh, 0.517. Well, we got a problem. So that tells me that I keyed something in wrong. So let's take a look. I have 18x cubed. Unless this is different than the one above. I thought it was the same. Let me double check. Now it's the same, so I should get the same answer, 1/9. So I must have keyed something in wrong. Let's see if we can figure out what it is. 18x cubed minus 2x squared, that looks good. Plus 2x, I lost my 7. Gotta have a 7 there. Come on. Alright, second, delete, so I insert a 7. Graph. Oh, that looks really skinny. I don't know, we could zoom in right here to make it look a little bit better. Gotta press enter twice when you zoom in, otherwise it won't do anything. Okay, I cleared it up a little bit. At least I can see better where it hits the x-axis. Second trace, finding a 0. I got x is 0 right now, so I gotta go to the right. There it is. Okay, so I'm to the left. Press enter. Arrow up to the right. Press enter. Would you like me to guess? Yes. And there's my 0.11111111. 0.1 repeating is 1/9. So that's how I can use my calculator to get the real answer anyways. Okay, so we're able to get the real answers using our calculator. The imaginaries, well, we'll show you next week how to handle that. I think what I want to do here is show you one more problem that is off your sheet because we have some off your worksheet that are a little bit different. So let me run through one more grouping one. This one here is number 9 off the worksheet that I'm giving you. If you're grouping, even if you're grouping, you should look to take out what they have in common. So these are all even. I highly encourage you to say, hey, we're going to take a 2 out first, and then group after that. So I'm just dividing these all by 2. And then now go ahead and break them up. Oops, should have got, let's go back. There we go. I want to include that square. I can group these 2 here and see what we can do. Hopefully this will work out. Don't lose your 2. The 2 is part of your final answer. What goes into 48n cubed and 42n squared? 6n squared. And that would go in there 8n minus 7 times. What goes into 56n and negative 49? Well, positive 7. We'll go in there 8n minus 7 times. And that's what I wanted, 8n minus 7. So I got 6n squared plus 7, 8n minus 7, and then there's a 2 that needs to go in front. That's the factorization there. If you wouldn't have taken out the 2 right away, it'd still work, but then you'd get something where you have to factor a 2 out. You know, you might have had something that ended up looking like this, 12n squared plus 14, 8n minus 7. Then you got to say, you know what, 2 goes into both of these. So you take the 2 out, and then you get the exact same answer that you had here. So keep that in mind. You can avoid that extra step if you take out what they have in common first. So that's our lesson on grouping. Thanks for watching. Have a great day.